This is the video lesson for Introduction to Electromagnetic Waves. The learning target for this lesson is, I'm learning to analyze the characteristics and behaviors of electromagnetic waves and the electromagnetic spectrum. The success criteria for this lesson are, I can analyze the characteristics of electromagnetic waves, I can analyze the behavior of electromagnetic waves, I can analyze the electromagnetic spectrum, and I can determine how electromagnetic waves are located on the electromagnetic spectrum. So what are electromagnetic waves? First and foremost, electromagnetic waves are light. All the light that we see are made up of electromagnetic waves. Other types of radiation, other types of things like X-rays, as well as ultraviolet light and radio waves, all those are electromagnetic waves as well, and we're going to get into all of that as we continue through this lesson. But the main thing to get out of this lesson, or one of the main things, is that electromagnetic waves are light. So electromagnetic waves are transverse waves that can propagate through a vacuum, and only electromagnetic waves can move through a vacuum. All other types of waves have to have a medium. So electromagnetic waves have electric fields and magnetic fields, both oscillating perpendicular to the direction of wave propagation. So if this is the direction that the wave is propagating, we have an electric field oscillating this way. And then we have a magnetic field oscillating perpendicular to that electric field, as well as to the direction that the wave is propagating. And all electromagnetic waves propagate in a vacuum at the speed of light. And the speed of light we call c, which is 2.99 times 10 to the 8 meters per second, or we could say 3 times 10 to the 8 meters per second, or we could call this 300 million meters per second. So 300 million meters per second, so very, very fast, and nothing in the universe travels faster than the speed of light. All right, so here we have an animation of an EM wave propagating through a vacuum. So the x-axis here is the direction that the wave is propagating, and we can see the electric field and the magnetic fields are oscillating perpendicular to each other, as well as the x-axis. So the electric field is in blue and the magnetic field is in red, and you can see them just oscillating as they move. So this is a good animation of an electromagnetic radiation, or electromagnetic wave. Okay, so a little bit of continuation as to what are electromagnetic waves. So EM waves are created by the changing of electrons from one energy level to a different energy level. So this is for infrared, visible light, X-rays. So all the types of light besides the most high energy light are created by electrons moving from one energy level to a different energy level. So if we have the nucleus of an atom, and then we have electrons out here floating around, if a photon of light strikes an electron with just the right amount of energy, that electron moves up to a higher energy level. And when that electron loses that higher energy, it loses a photon of light at that same exact amount of energy that it gained when it was excited to that higher level. And when it loses that energy is emitted as a photon of light, and then the electron goes back down to its lower energy state. And so that energy is absorbed as a photon of light, and then it is emitted again as a photon of light from that same energy level. And so that is how EM waves are created for the most part. There is one other way that EM waves are emitted, and that is from radioactive decay or from nuclear fusion. Those create gamma rays. So these are the most high-powered, the shortest frequency, the shortest wavelength, highest frequency, highest energy EM waves are gamma rays, and they're created from radioactive decay and nuclear fusion. All right, let's talk about the electromagnetic spectrum. So different types of electromagnetic waves are categorized on the EM spectrum by wavelength and by frequency. So we have long wavelength, low frequency waves have low energy. And then moving across the spectrum, which we'll look at in just a minute, we have shorter wavelengths, higher frequencies, and higher energy types of waves. And so if we look at the EM spectrum, looking at from the left side, low energy waves, to the right side, high energy waves, we start with radio waves. We move on to microwaves, infrared light, then visible light. This is the light that we can see. This is all the light that we're familiar with. So this would be the colors of light, which would be Roy, G, Biv. And then we get to ultraviolet light, X-rays, and then finally the highest energy light of all, which would be gamma rays. Okay, so here's our EM spectrum. So we have lots of information on this animation, or on this illustration here. So we have the radiation type and the wavelength. We have an approximate scale of the wavelength here. We have the frequency, and then we have the temperature of objects at which the radiation is most intense. So that's down here, the temperature. And up here we have whether or not this type of radiation or this type of EM wave passes through the atmosphere. So we start over here on the left side with the longest wavelength and the shortest frequency, or the smallest frequency, or the highest frequency, excuse me. So we have radio waves have the longest wavelength. So we have 10 to the third. So that's a kilometer or greater wavelength. So these are huge wavelengths, super long wavelengths. And we have a really low frequency. So 10 to the fourth frequency. Then we get into microwaves, then infrared, then visible. So all the time the wavelengths are getting shorter and shorter. So for visible light, we're talking about wavelengths the size of microbes. We get into ultraviolet next, then X-rays. By the time we're at X-rays, we're talking about the size, wavelengths the size of atoms. And then when we get to gamma rays, which are the most high-powered, the wavelengths are the smallest wavelengths. We're talking about wavelength sizes the size of atomic nuclei. And frequency-wise, as we move from right to left, or excuse me, from left to right, we're getting higher and higher frequencies. So by the time we get to gamma rays, our frequencies are really high, 10 to the 20th frequencies. For visible light, we're somewhere in here between 10 to the 12th and 10 to the 15th hertz in terms of our frequencies. You may have heard of the term electromagnetic radiation. We're going to look at that. So EM waves are sometimes called EM radiation. So we have different types of EM radiation. We have ionizing radiation. These are gamma rays, X-rays, and some ultraviolet light. So ionizing radiation is the type of radiation that can do damage to the human body. And we have non-ionizing radiation. Non-ionizing radiation would be visible light, infrared, microwaves, radio. So these wavelengths of non-ionizing radiation are so large that they don't interfere with the parts of our bodies that could do damage. Whereas ionizing radiation, the wavelengths are so small, gamma rays, remember, the wavelengths are small enough, they're as small as atomic nuclei. So when a gamma ray hits a human body, they can do real damage to our body. X-rays, the same thing. X-rays have really small wavelengths, so they're small enough that they can hit a human body and do real damage to us. We know ultraviolet light can give us skin cancer. So some EM radiation is blocked by the atmosphere, thankfully. So microwaves don't come through our atmosphere. That's good because we would all get cooked. Some UV light is blocked by the atmosphere. That is what the ozone layer does. So only a portion of EM light from the sun gets blocked by or comes through our atmosphere. X-rays and gamma rays, for the most part, are all blocked by the Earth's atmosphere. So we are able to live a happy life on the Earth with most of the highest powered, most dangerous radiation created by the sun and other sources in space blocked by our atmosphere. So we are safe from most of that radiation. So we do not get cancer and things, on the most part, from all of these high energy electromagnetic radiation coming from outer space, thanks to our atmosphere. All right, keep asking questions. It's how you learn new things.